A thermal power plant is a large-scale electricity generation facility that converts heat energy into electrical energy through a complex and interconnected system. It plays a crucial role in meeting the growing energy demands of societies around the world. By harnessing the thermal energy released from the combustion of fossil fuels or nuclear reactions, thermal power plants provide a reliable and consistent source of electricity of residential, commercial, and industrial purpose. The primary objective of a thermal power plant is to efficiently convert thermal energy into electrical energy. The process involves a series of interconnected steps, each contributing to the overall generation of electricity. These steps include fuel combustion, heat transfer, energy conversion, and power transmission. Thermal power plants are vital electricity generation facilities that convert thermal energy into electrical energy through a complex and interconnected system. By utilizing fuel combustion or nuclear reaction, these power plants provide a reliable and consistent source of electricity, contributing to the development and growth of societies. While thermal power plants have been instrumental in meeting the global demand for electricity, they also pose environmental challenges. The combustion of fossil fuels release greenhouse gases and pollutants, contributing to climate change and air pollution.
Next is water source and availability. The source of availability of water for cooling purpose influence thermal discharge. Power plants located near large water bodies or rivers often have access to abundant cooling water, which can aid in heat dissipation. Conversely, power plants in arid region or those relying on limited water source may face challenge in managing thermal discharge due to water scarcity. The last one is discharge point and flow rate. The location and flow rate of the discharge water can impact the dispersion and dilution of heat in the receiving water body. The proximity of the discharge point to sensitive ecosystem or areas with higher ecological value determine the potential environmental impact. Adjusting the flow rate of the discharge water can help disperse heat and minimize the localized thermal impact.
Moving to the effect. Significant amount of cooling water are used in thermal power plants with the steam generator and one-stroke cooling system for condensing steam, turbine exhaust, and cooling auxiliary equipment. Because many aquatic creatures are biologically sensitive to changes in water temperature. Temperature rises brought on by water plant discharges may have a variety of effects on aquatic ecosystems. Direct impact and indirect effect are the two main categories of thermal discharges effect on the aquatic environment. The direct effect of thermal discharges on the water environment include a change in the temperature regime of the water column, and in some cases the sediment leader and sub-leader response of water organism to the change in temperature regime. Stimulation of productivity in a variety of organisms leading to increased respiration rates. Changes in distribution, composition, and growth rates of communities of water body creatures including fish and microvertebrates. Implication on the distribution of bird population dependent on this are only a few of the indirect consequences of thermal discharges on the aquatic environment, alter nutrition and carbon cycling in organisms.
The regulations and procedure can be followed for thermal discharge is a efficient cooling system. Implementing efficient cooling system is crucial to reduce the temperature of the discharge water. Cooling towers are commonly used, which transfer heat from the water to the atmosphere through evaporation. Cooling ponds or lagoons can also be utilized, allowing for natural cooling through heat dissipation. Advanced cooling technologies such as closed-loop cooling systems or hybrid cooling method can further enhance the cooling efficiency. The next procedure or regulation can be followed is thermal mixing zones. Establishing thermal mixing zones can help dissipate the heat from the discharge water and minimize the thermal impact on the receiving water body. These zones allow for the bending of discharge water with the ambient water, facilitating natural cooling and reducing the temperature gradient. The size and location of the thermal mixing zone should be determined based on the specific characteristics of the water body and the anticipated thermal effects. In addition, flow management can also be followed in the regulation and procedures of thermal discharge. Proper management of the flow rate and velocity of the discharge water can contribute to temperature reduction. Adjusting the flow rate can disperse the thermal plumb, allowing for better heat dissipation. Controlling the velocity can prevent the accumulation of heating water in specific areas, minimizing the localized thermal impact. Last but not least, environmental monitoring. Implementing a comprehensive environmental monitoring program is essential to assess the effectiveness of preventive measurement and ensure compliance with regulatory requirements. Regular monitoring of water temperature, water quality parameters, and the ecological health of the receiving water body can help detect any potential impact and guide the adjustment of mitigation strategies if necessary.
Conclusion. In conclusion, thermal discharge is significant environmental concern associated with various industrial processes including thermal power plant and manufacturing facility. The release of heated water or substance into the water body can have adverse effect on aquatic ecosystem, water quality, and the organism that rely on this ecosystem for survival. Efficient management of thermal discharge is essential to minimize the ecological impact and ensure the long-term sustainability of water resources. Regulation, procedure, and best practice to have been established to control the temperature of discharged water and mitigate potential harm. These measures include setting temperature limit, implementing effective cooling system, establishing thermal mixing zone, and monitoring water quality parameters. The responsible management of thermal discharge requires collaboration among regulatory body, industry, and environmental stakeholders. By complying with regulation, adopting sustainable practice, and invest in innovation technology, industry facilities can minimize their environmental footprint and reduce the thermal impact of their discharge. Ultimately, the goal is to strike a balance between industrial activity and the preservation of water resources and ecosystem. By mitigating the adverse effect of thermal discharge and promoting responsible practice, we can protect the health and integrity of water bodies, safeguard biodiversity, and ensure a sustainable future for generation to come. That's all for me.